Before we proceed into the actual driver app work and push notification, we need to implement all the infrastructure in the server side. I also need to implement some changes we need in the protocol. Let's start by looking at the Uber class. I had to add 3 new fields and modify/add some methods. Hailing from and hailing to allow us to communicate our trip details with the driver community. I need the push token of drivers so we can hail them directly from the app. I'll discuss the RideDAO class soon. It allows us to send details about the trip to drivers. Not much of a change, but I added the push token to the UserDAO factory method. Ride isn't as simple as RideDAO despite their common name. It contains far more information. Currently we don't use all of that, but the fact that it's logged will let you provide all of that information within the app or a management app easily. The Ride class is a JPA entity, similar to the user class. I used an auto increment value for the ID instead of a random string. I wanted to keep things simple. But notice this can expose a security vulnerability of scanning for rides. The passenger and driver are relational database references to the respective database object representing each one of them. The route itself is a set of waypoints sorted by the time associated with the given waypoint. We'll discuss waypoints soon enough, but technically it's just a set of coordinates. I really oversimplified the cost field. It should work for sum and currency, but it's usually not as simple as that. It's important to use something like big decimal and not double when dealing with financial numbers, as double is built for scientific usage and has rounding errors. We have 2 Boolean flags. A ride is started once a passenger is picked up. It's finished once he is dropped off or if the ride was cancelled. The companion crewed RideRepository is pretty standard with one big exception. I added a special case finder that lets us locate the user that is currently hailing a car. Notice the syntax b.driver.id equals $1, which points through the relation to the driver object. The waypoint entity referenced from the ride entity is pretty trivial. Notice we still need a unique ID for a waypoint even if we don't actually use it in code. The interesting part here is the time value, which is the value of system current time millis. This allows us to build a path based on the time sequence. It will also allow us to reconstruct a trip and generate additional details such as speed, cost, if we wish to do that in the future. Notice that there is also a Waypoint repository interface. I'm skipping it as it contains no actual code. The RideService class serves the same purpose as the UserService class, focusing on rides and driver-related features. I could have just stuck all of this logic into one huge class, but separating functionality to different service classes based on logic makes sense. We manipulate both the rides and users crewed objects from this class. Hailing is a transactional method. This means that all operations within the method will either succeed or fail depending on the outcome. This is important to prevent an inconsistent state in the database. This method can be invoked to start and stop hailing. In this case, we use the assigned user property to detect if a driver accepted the ride. If so, we return the driver data to the client. When a driver gets a notification of a ride, he invokes this method to get back the data about the ride. If the driver wishes to accept the ride, he invokes this transactional method. The method accepts the token from the driver and the ID of the user hailing the ride. It creates a new ride entity and returns its ID. From this point on, we need to refer to the ride ID and not the user ID or token. Start ride and finish ride are invoked by the driver when he picks up the passenger and when he drops him off. Normally, finish ride should also handle elements like billing, etc. But I won't go into that now. The next step is bringing this to the user through a web service. The RideWebservice class exposes the RideService call almost verbatim to the client. The GET call fetches the ride DAO for the given user ID. Start and finish rides are again very simple, with only one argument, which is the ride ID. We also have to add some minor changes to the UserService and LocationService classes. Let's start with the UserService class. Drivers need a push token so we can hail them. This is always set outside of the user creation code for two reasons. The first time around, the user is created, but the push key isn't there yet. It arrives asynchronously. Push is re-registered in every launch and refreshed, so there's no reason to update the entire object for that. The UserWebservice class needs to mirror these changes, obviously. There isn't much here. We just added a new setPushToken URL, and we accept this update. The LocationService needs a bit more work. Every time we update a user's location, we check if he's a driver on a ride. Assuming we have a ride object, we check if this is currently an ongoing ride that wasn't finished. If so, we add a waypoint to the ride and update it so we can later on inspect the path of the ride. This pretty much tracks rides seamlessly. If we wanted to be really smart, we could detect the driver and user position to detect them traveling together and automatically handle the ride. There are obvious problems with this, as it means a user can't order a cab for someone else. But it might be an interesting feature since we have two close data points.